Today we'll want to solve quadratic equations using the square root property. Our objectives will be to simplify square roots first, then identify when the square root property can be used, and solve using the square root property. So let's begin by looking at square roots, and in order to do this we'll need to identify what we call perfect powers. I've given you a table here, and I realize that you may already know many of these, but if not, you need to be very familiar with them. These are what we call perfect powers. In this table, if I take 1 and I square it, I get 1. If I square 2, I get 4. And so on all the way across. If I square 6, I get 36. And it's these numbers down here that we really want to pay attention to because we're going to be working backwards with these square roots, trying to pull out perfect powers where they exist. So let me now show you how we're going to use these. If I ask you for the square root of 25, well, it's the number that times itself gives you 25. So in this case, it would be 5. Let's do another one. What if I ask you, what is the square root of 0? What number times itself would give you 0? Well, it's just a 0. Let's go a step further. What about the square root of a negative 16? In case you don't remember or haven't heard this one before, the square root of a negative number has no real solution. There are complex numbers, but in this course we will not be dealing with them. I want to focus then on some numbers where we want to simplify the square root, but it's not a perfect square. One such example is the square root of 50. The way we'll approach this one is that we will rewrite it into two pieces. Would you agree that 25 times 2 is 50? Well, what I've done is I've broken it down into two separate square roots, but so that this one is a perfect square. It's right here. When I do that, I can then take the square root of 25 and I'll get 5 times the square root of 2. Can't do anything else with this part, but I can the first part of it. So I end up with 5 times the square root of 2. Let me give you another one, the square root of 40. You may want to stop the video and see if you can do this one. It would factor into 4 times 10, where 4 is a perfect square. That would give me 2 times the square root of 10. Let's look at another one. What if I gave you 32? Now you may tell me that that would factor into 4 times 8, and that is correct, and it's even correct that this is a perfect square, but what we want is the largest perfect square that there is. So the correct way to do this one would be to tell me it's the square root of 16 times the square root of 2. This is the largest perfect square that can be pulled out, so I would get 4 times the square root of 2. If you did this one up here, you would end up with 2 times the square root of 8, but remember this could be broken down again into 4 times 2, another perfect square. So the correct final answer for this one would be 4 times the square root of 2. Now you will need to know how to simplify radicals in order to carry on with what we've got to do. So if you need to stop and practice a few more of these, feel free. What we want to do now is we want to examine the square root property. So let me tell you what mathematically it says first. It says if we have x squared is equal to k, where k is a positive number, then it's legal for me to write this next line. X is equal to the plus or minus square root of k. This symbol right here, if you haven't run across it before, says plus or minus, meaning we get two answers. One of them is a positive square root of k, and the other one is the negative square root of k. You could just as easily have written that like this: a positive square root of k and a negative square root of k. Two separate answers. Now let's see how this works. If I give you this problem, x squared is equal to 9. The question is, can I solve this quadratic equation by using the square root property? And the answer is yes, I can. The left side is x squared, so I get an x. And the right side is 9, so I get x is equal to plus or minus the square root of 9. Now you need to let that thought sink in and make sure you understand how each side of that behaves. This side, it's whatever the perfect square of x squared is. In this case, it's an x. And on the right-hand side, it is always plus or minus the square root of whatever number you had. But can I simplify that? Well, x is equal to plus or minus, what is the square root of 9? Well, that's just a 3. And I do want to go one step further. Now this is not necessary, but I do want to make sure that you understand completely what you have here. You have two answers, one of which is x is equal to 3, and the other one is x is equal to a negative 3. Now let's take this one step further. What if I gave you this quadratic equation? Now I know that you could graph it and you could look at the intercepts, and you may even be able to factor this one. But if you cannot, can we do it using the square root property? And the answer is yes, we can. Our first step would be to write it where we have a perfect square on the left-hand side, and it's equal to some number. Now notice, I said this is a perfect square. Tell me what times what gives you 4x squared. Well, hopefully you realize that 2x times 2x would give you 4x squared. So it is indeed a perfect square. So what I have now is 2x is equal to, and remember, this plus or minus must be there, the square root of 16. When I simplify that, I get 2x is equal to plus or minus 4. And remember, that's like two separate answers. So 2x is equal to 4, or 2x is equal to a negative 4. Can I now solve both of those? Well, x is equal to 2, or x is equal to negative 2. I still get the two answers. If I drew the picture of it, the graph would have two x-intercepts, and they would be located at 2 and negative 2. Let's take another one. Now this one looks a little different, but I want to make sure that you understand. All that is required for us to use the square root property is that this side over here has to be a perfect square. Well, the perfect square of that squared is just x plus 2. Remember a minute ago when it was x squared, you told me it was x? Well, it's what times itself would give you x squared. Well, what times itself would give you x plus 2 squared? Well, it's just x plus 2 is equal to, remember your plus or minus, the square root of 25. Let's keep simplifying though. The left side is just x plus 2 is equal to plus or minus 5. Let's keep going. Remember, it's like two separate answers. So it's x plus 2 is equal to 5, or x plus 2 is equal to a negative 5. And I think you're now in a position you could solve both of those. So I would get x is equal to 3 on the left, and x is equal to negative 7 on the right. Let's look at a couple of more examples. What if I had x squared is equal to 12? Now, even though this side over here is not a perfect square this time, we can still do that. This side is required to be a perfect square, but this side is not. So let's look at what happens. I would get x is equal to plus or minus the square root of 12. This is where reducing radicals that we did at the beginning comes in handy, because what we need to do is simplify this radical. The way we can do that is this. X is equal to plus or minus, and we'll break this down into two radicals where one of them is a perfect square. That leaves us with x is equal to plus or minus 2 under the square root of 3, or 2 times the square root of 3. I didn't write it here, but let me go on and do this. You actually have two separate answers. You have this and you have this. Two separate pieces. You've written them together here, and it looks like one answer, but you actually do have both of them. Let's look at one more here. We have x squared is equal to 13. This time I would get x is equal to plus or minus the square root of 13. Let me ask you, is there any factor in that that is a perfect square? The answer to that is no, there's not. So my final answer here is x is equal to plus or minus the square root of 13. There's one more thing I need to make sure you understand. The square root property is particularly useful anytime you have a quadratic where b is equal to 0, meaning there's no x term. You have an x squared, and you have the term that doesn't have an x with it. Anytime I have a problem where b is 0, meaning there's no x term there, my method for solving that will always be the square root property. Your first step would be to rewrite it where you have the perfect square on the left-hand side, and then apply the square root property. Can I simplify this? If the answer is no, then I'm done. X is equal to plus or minus the square root of 15, and in this case I am finished. It's those problems that are particularly easy to do using the square root property. So please file that away for later on when you have to start making choices in which method to use. Let me leave you now with my thought for the day. It is a mistake to try to look too far ahead. The chain of destiny can only be grasped one link at a time. It's a lot like algebra. Don't try to look too far down the road. Simply do what we're doing today. At this point, I need you to be able to solve quadratics using the square root property. I'll see you again soon. Bye-bye.